So next up, we're going to take a close look at correlation. Correlation measures the relationship between two variables. So we would say positive correlation exists when, as one variable increases, the other one also increases. And then we would say there's negative correlation when we find that as one variable increases, the other one decreases. And then sometimes we find that there's no correlation at all. And here you see that I've written there's no identifiable pattern between the changes in the variables x and y. So sometimes we just find out that there is no relationship. Let's look at some examples. Here you will see an example of positive correlation. And if you remember from the previous slide, positive correlation is when we find that as one variable increases, the other one also increases. So this is a graph showing the cases of stolen identity out of 100 by age. And so on the bottom line, 20, 30, 40, 50, 60, 70, that's capturing age. And then over on the left, we're looking at cases of stolen identity out of 100 people. And so you see that the line increases, it goes up from left to right. And that's our best clue that we're looking at positive correlation. When the line looks like that, like an uphill climb from left to right, you're likely looking at positive correlation. And what that means in simple terms is that as age increases, the cases of stolen identity also increase. And you might think, okay, well, that kind of makes sense. Sometimes we hear that older people are particularly vulnerable to this type of victimization. And so maybe this data then makes sense to us and is not too surprising that as you get older, maybe we find more cases of stolen identity. Here we're looking at an example of negative correlation. You'll see the line slopes down now from left to right. It's no longer an uphill climb, it's a downhill climb from left to right. In this case, we're looking at the number of times a person's been assaulted by an intimate partner in the last year, again, by age. And so same line at the bottom says 20, 30, 40, 50, 60, 70. Again, that's representing age. And then on the left-hand side, the y-axis, you'll see number of times assaulted by an intimate partner in the last year. And you see that the line slopes down. That means that as age increases, we find a decrease in the number of times a person is assaulted by a loved one. And again, you might, if you're familiar with this research, you might think, well, that does make sense because we find that cases of intimate partner violence are much greater at a younger age. In fact, we see very high numbers of relationship violence among teenagers and young adults. And so this data, again, might not surprise you very much, but it is an example of negative correlation. As age increases, assaults decrease. And then here's an example where we may say there's maybe no relationship between the variables. The line doesn't appear to be clearly going up or down. It's kind of moving up and down. And so we would say in this case, just by looking at this line, that maybe there's no correlation or no relationship between the variables. But just to finish the thought, what we're looking at here is, again, age at the bottom, age 20 to age 70. And then on the y-axis, we're looking at percentage of people who reported experiences of racial discrimination by the police. And what we're finding here is that maybe there's no relationship by age, which tells us that at any age, you're about equally as likely to experience racial discrimination by the police. Doesn't matter old or young, perhaps everyone is about equally as likely to experience this. I should note that these numbers are made up for demonstration purposes, but just to capture the idea that perhaps it's not age that is the factor here. So this was an interesting practice that I did with a class a couple of years ago. I asked them to complete some surveys, and then on those surveys, I asked them to report their age and the number of states that they had visited. And then I mapped out the data. And what I found actually surprised me, and I think it surprised a number of people in the class as well. I measured age against states visited and found that there was actually negative correlation. A slightly weak negative correlation, not a very strong relationship, but a negative correlation nonetheless. And what that means is that as age increased in the class, number of states visited actually decreased. And that was surprising to us because we would have predicted that as people get older, they accumulate more travel experience, and that those who were older in the class maybe had just more time on Earth to do some traveling and visit some states. And we found just the opposite, that it was the younger people in the class who had seen more states. And so this was just an example of one of those times when the data surprises you, and we didn't find what we thought we would find. Now, you heard me on the previous slide allude to the strength of the relationship. I said when I measured age against states visited, we found a negative correlation, but I said, admittedly, it's not a very strong negative correlation. It was a bit of a weak relationship. So let's take a look at how we measure the strength. You will often see this calculated with the correlation coefficient R. And so you'll see in your textbook that it refers to the R value. The R value is just measuring the correlation, and you will find that it is always a value between -1 and 1. If you see an R value of 5, something's wrong. That can't be. If the correlation coefficient is calculated correctly, R will always be a value between -1 and 1. Now the sign of the coefficient, the sign of your R value, tells you the direction of the relationship. So we've already spent some time looking at examples of positive correlation and negative correlation. But when you're looking at an R value, how do you know if it's positive or negative? You can't see the line sloping up or sloping down. But what you can see is if there's a negative symbol by it. So, -0.5, it would be a negative correlation, but just 0.5 would be a positive correlation. The most important thing to remember when looking at the R value is that the closer the value is to either -1 or 1, the stronger the relationship. And a lot of people get this confused because they would think -1 is negative, and people think that's bad, and people think that means weak value. But actually, an R value of -1 is considered perfect correlation in a negative way, perfect negative correlation. The same as +1 would be perfect positive correlation. You rarely see correlation that strong. What you will see are numbers that get close to it, though. And so we have some examples on the right-hand side. You'll see I have some R values, and I'm going to ask you to pause the video and see if you can rank them from strongest to weakest. And if you did that, this is what you may have found. That the strongest R value was actually -0.99. That is almost perfect negative correlation because it's almost -1. It's about as close as you can get to -1. So that's the strongest correlation that we see. If we mapped that out on a graph, we would see that line sloping down in a nearly perfect way. The next strongest one was 0.89. Now this is also very close, to +1. So if we were to put this on a graph, we would see an almost perfect line sloping up. The next one is 0.25, followed by -0.005, followed by 0.004, which would be the weakest correlation on this list.